Have you ever solved any mathematical problem in limits and wondering where you could actually use limits? I will show you the surprising real-life application of limits. First of all, have you seen something like this? What this simply means is that as x approaches 5, what's the value of 5 over x? That's what this is simply saying. You see, limit is a tool for finding the destination of a process, right? Limit is interested in the values of x as it approaches what? 5, or as it gets closer and closer to 5, right? Normally, if we plug in 5, if you substitute 5 into this function, what do we have? We have 5 over 5, right? Which is equals to what? 1. But limit is not only interested in 5 alone. Limit is interested in all the values that are infinitely close to 5. Is that not so? Okay. Which other values is infinitely close to 5? We can choose 4.99999. You see that this value is very close to 5. Now let's substitute this value into this function and see what will happen. If you substitute this value into this function, it will become 5 divided by 4.999999. Now when you do this division, you will see that you will still get the value of what? 1. So this is what limits is all about, right? It's a tool for finding the intended destination of a process. You can decide to choose any other number, right, that is infinitely close to 5. You see that when you do the division, you will still get what? 1. Now let me explain the practical aspect of limits. Now yes, Taiwo, right? Taiwo wants to journey from this point A, right, to point W, which is the wall, right? Now, to explain the application of limits, there must be a rule. The rule is that Taiwo will continue to walk half of the journey, right? We know that Taiwo wants to get to the wall, right? But the rule is Taiwo will continue to walk half of the journey, right? Now let's say the journey between point A and point W is 10 meters, right? Now let's apply the rule. Now it simply means Taiwo will journey from point A to half of 10 meters. And what's the half of 10 meters? 5 meters, right? That means Taiwo will journey to this point, right? Then the remaining journey will be what? 5 meters. What's the rule? Taiwo will continue to walk half the journey. Now Taiwo will also move again from here to half of this journey, which is what? What's the half of 5 meters? The half of 5 meters is what? That's 2.5 meters, right? So 2.5 meter. Now again, Taiwo will continue with journey again from this point to half of this journey. And what's half of 2.5? The half of 2.5 is 1.25, right? Okay, 1.25. He has journeyed to this part. Now the rule says Taiwo will continue to walk half the journey. Now Taiwo will journey again from this point to half of 1.25. And what's the half of 1.25? That's 0.625, right? 0.625, which is somewhere here, right? Now Taiwo again will journey from this point, right, to half of 0.25, which is the distance that is left. And what's the half of 0.625? The half of 0.625 is 0.3125, right? Now, which is somewhere here. Now Taiwo again will journey from this point to this point, which is 0.3125, which is the distance left. And what's the half of 0.3125? The half of 0.325 is 0.15625. You will see that if we continue to apply this rule, you see that Taiwo will never get to the wall, right? Taiwo will never get to the wall, but you will never get 0, right? It simply means Taiwo will never touch this wall, right? But he will keep getting very close to the wall. Thank you. So if this video actually explained the application of limits, like, share and comment. Thank you very much.